Hi, Science 30s. This is Mr. Riley here. I just want to make a quick video on sort of an introduction to organic chemistry. Organic chemistry sounds a little bit scary, but really it's not. And I think it's going to be sort of the favorite part of chemistry for this course for a lot of you guys. So what exactly is organic chemistry? It is the study of carbon-containing compounds. And mostly we're talking about molecules. And the ones we're going to be talking about today are called hydrocarbons. And those are molecules that contain hydrogen and carbon only. Okay. Let's take a little look here at carbon and these molecules and kind of what makes carbon special. So when we're looking at a diagram of carbon here, so let's look at this diagram here. So this is a Bohr diagram you guys probably recognize. In the nucleus, carbon, if we look over here, is number 6 on the periodic table. That means it has 6 protons in the nucleus, and it also has 6 electrons. And those electrons are arranged in what we call energy levels or shells. In this model of the atom, the first shell can hold 2, the second shell can hold 8, the third shell can hold 8. And then after that, things get a little bit more complicated. But we notice here the first shell has 2. The second shell has 1, 2, 3, 4 atoms. So carbon actually wants to have 8. So it needs to go and find some electrons. And what it's actually going to do is it's going to form covalent bonds with other atoms. So those are sharing bonds. So carbon wants to make one bond here, one bond here, one bond here, one bond here. It wants to make 4 bonds. Okay. Now, when we're talking about chemical bonding, we're really only worried about that outer shell. So we can change to a different type of diagram called a Lewis diagram. And so I'm going to use the symbol C for carbon, and I'm just going to draw those 4 valence electrons. Okay. And remember, carbon wants to make 4 bonds. Okay. Now we're dealing with hydrocarbons here. So hydrogen, if we go over to hydrogen, hydrogen is going to just look like this. It has an H and then 1 valence electron. So hydrogen actually only wants to make 1 bond because hydrogen, as we know, is in that first row, that first period on the periodic table, and it only wants 2 electrons to be content. Okay, so hydrogen wants to make 1 bond. Oxygen, if we look at oxygen, oxygen has 6 valence electrons. So if we start drawing those, we have these 4 bonding regions, and then the electrons start to pair up. So oxygen can't make a bond in either of those regions. Those are called lone pairs. Oxygen wants to make 2 covalent bonds, and hydrogen, carbon, and then oxygen. Those are the 3 atoms that we're going to be looking at. So what hydrogen would do is it would take itself over here, and it would share carbon's electron with its own to create what's called a bonding pair or create a covalent bond. Okay. Now instead of these dots, we can show these bonds with just lines, and we would call that a Lewis structure. So I have down here the very simplest hydrocarbon in the universe, and that is called methane. And you guys know methane from natural gas. You use it to heat your homes, probably the water in your home as well. And it is a really important molecule for us. And you guys have all heard this before. The chemical formula is CH4. That means 1 carbon and 4 hydrogens. And I could replace these bonds with 2 electrons that we would call a bonding pair, but I think it's just easier to draw the line. So that's called the Lewis structure when we have the lines like that. Okay. Now this molecule is called an alkane. So an alkane is a hydrocarbon that contains single bonds only. So if we look in our data booklet, we have alkanes. And they only contain single bonds, and there's actually a general formula to figure out how many hydrogens. So if you know how many carbons, you can figure out how many hydrogens, and that is whatever the number of carbons there are, the number of hydrogens is 2 times that number plus 2. And we'll take a look and kind of see why that is. So let's look at the first 4 alkanes here. So ethane is another hydrocarbon. Now, meth stands for 1. And that means it's a 1-carbon compound. Now, if we look over in our data booklet, we have this handy chart. So meth means 1 carbon. Eth means 2 carbons. So if I look at ethane, ethane is going to have 2 carbons. And I can do that little formula to figure out how many hydrogens there would be. I can say, okay, 2 times the number of carbons plus 2. So I'm going to take 2 times 2 plus 2 makes 6. So C2H6, that's ethane. And the way I would draw that, I would say, okay, my 2 carbons bonded, and then you're always going to find hydrogens on the outside of the molecule because hydrogens can only make 1 bond. And I also want to make sure that all of my carbons have 4 lines around them, signifying that they have built 4 bonds. Okay. Now let's look at propane. So propane is 3 carbons. So how many hydrogens would there be? So it would have to be 3 times 2 plus 2. And so that's going to be 8. So C3H8 is your barbecue fuel propane. And we can draw that like this. 3 carbons, and then we're going to surround that with hydrogens. And I'm going to draw it a certain way here. So we see here 3 carbons times 2 hydrogens each, and then the plus 2 comes from these 2 hydrogens that are going to go on the end. Okay, so there's propane. Now butane, let's do this one a little bit differently. Butane is 4 carbons, so 4 times 2 plus 2 is 10. And butane is like lighter fluid. Now we're going to do the condensed formula for this one. So I'm going to draw my carbons in here. So I have 4 carbons. And my 4 carbons are each going to be surrounded by a number of hydrogens. So instead of drawing this whole part right here, I'm going to say that this carbon here has 3 hydrogens surrounding it. So this one would be CH3. The second carbon would have a hydrogen at the top and a hydrogen at the bottom. So it would be CH2. The third would be the same. It'd have a hydrogen up here, hydrogen here, CH2. And then always the ones on the end are going to be CH3. So that is called the condensed formula. It's another way to show that molecule that once you get to a bigger molecule, it's a little bit easier to draw. Okay, so that along with your notes, I hope that helps you guys. And please let me know if you have any questions. Bye-bye.